You are welcome to my class today. Please always subscribe to my videos. Now, today, I'll be taking questions on gas laws. Very important questions on gas laws. Now, if you look at the board, it's already showing question 1 already. Question 1 says, calculate the energy in joule of a gas occupying a volume of 1,500 centimeter cube and exerting a pressure of 20 atm. Now, if you want to solve this question, let us bring out our parameters. We are giving volume to be equals to 1,500 centimeter cube and pressure is given to be 20 atm. We are asked to find what? The energy. Remember, we have to find the energy in joule. The energy must be in joule. And remember that joule is actually what? Newton seconds. That is force times, Newton meter. That is force times distance. That is joule, which is energy. Now, but here we are giving volume to be in centimeter cube. But for us to get the energy in joule, our distance must be in meter. So we have to convert this centimeter cube to meter cube. How do I convert 1,500 centimeter cube to meter cube? You multiply by a factor of 10 minus 6, which will be equals to exactly 1,500 times 10 minus 6. Then it becomes in what? In meter cube. Then also we have to convert 20 atm, okay, which is a pressure. So our unit for pressure should not be in atm. If we want to get energy in joule, the unit should be in Newton per square meter. But remember that 1 atm is equals to 1.0135 times 10 raised to 5 Newton per square meter. If 1 atm is equals to this, that means 20 atm should be equals to 20 times 1.0135 times 10 raised to power 5. Okay, so this place, which is 20 atm, we need to convert it to Newton per square meter. It becomes 20 times 1.0135 times 10 raised to power 5, then Newton per square meter. All right. Now, having done this, we can now get our what? Energy. Remember, mechanical energy is equals to pressure multiplied by volume. The energy of a gas is equals to the pressure of the gas multiplied by the volume of the gas. That will exactly be the pressure, which is 20 times 1.0135 times 10 raised to power 5 Newton per square meter. Then multiply by the volume, which is what? Times 1500 times 10 raised to power minus 6, okay, in meter cube. Of course, when you multiply this thing out, you will get the answer in joules. Okay, if you multiply 20 times this, multiply by 1,500 times minus 6, the answer you will get will be exactly in what? In joules. That is question number 1. Now let us go to the next question. Having seen the procedure you can use to solve this, we can go to the next question. I will be writing out the questions. I will not be dictating it so that everyone can see it. Now the second question says, calculate, okay, it says number 2 questions. The Boyle's constant is dash. The Boyle's constant is dash. This is options. There is options. Option A, pressure. Option B is energy. Option C, okay, we have temperature. And option D here, we have volume. So the question says the Boyle's constant is dash. Which of these options represent the Boyle's constant? Now, what is Boyle's law? Let's take solution. Let's go to Boyle's law so that we can get the Boyle's constant. Boyle's law states that volume is inversely proportional to pressure. Okay? If we introduce a constant, volume will become equals to constant over pressure. What does it mean? It simply means that what? The constant become equals to pressure multiplied by volume. That is, if we cross multiply. Now, therefore, it simply means that Boyle's constant K is equals to pressure multiplied by volume. Pressure multiplied by volume is exactly what? Energy. What it simply means is that Boyle's constant K is equals to what? Energy. So the answer is what? B. Remember, there is this difference between what did Boyle keep constant in his experiments and what is Boyle's constant. What Boyle kept constant in his experiments is mass. Okay, he kept mass constant. He also kept temperature constant. What he kept constant is mass and temperature. But Boyle's constant K is equals to what? Energy. How do we show that what? That PV is energy? We can show it using units and dimension. Remember, pressure is in Newton per square meter multiplied by volume. Volume is meter cube. That means that what? By indices, you have Newton meter minus 2 plus 3, which is equals to Newton meter. Remember, Newton meter simply means force for Newton multiplied by distance for meter. And force times distance is equals to what? Energy. That is to prove that what? That PV is equals to energy. So the Boyle's constant is equals to what? Energy. That is question 2. I hope you are clear. Let us go to the next question. I have some other questions for us today. We are looking at question 3 now. Question 3. Question 3 says, what is the weight of oxygen gas? What is the weight of oxygen gas, which when collected over water? Weight of oxygen gas which when collected over water at 752 millimeter and 22 degrees Celsius occupies a volume of 46.2 centimeter cube. Okay, the vapor density of water at 22 degrees Celsius is 20 millimeter. Okay, that is the third question. What is the weight of oxygen gas which when collected over water at 752 millimeter and 22 degrees Celsius occupies a volume of 46.2 centimeter cube? The vapor density of water at 22 degrees Celsius is 20 millimeter. Now, that is to say that this oxygen gas is collected over water. Now, and we know that the pressure of gas collected over water is equals to the pressure when the gas is collected over water is equals to, okay, the pressure of a gas collected over water is exactly equals to what? 752 millimeter minus 22. Okay, is it 22? Okay, 20 minus 20 millimeter. Now, because oxygen is collected over water, you will see that what? That the total pressure will become pressure of that oxygen plus pressure of what? Of water vapor. Total pressure when a gas is collected over water is equals to what? The pressure of that gas collected over water plus the pressure of water vapor. That means the pressure of the oxygen, which is PO, will be equals to the total pressure given to us, 752, then minus the pressure of water vapor. If we do that, we see that the pressure of oxygen, P, will be equals to 732 millimeter. Okay? What are other parameters given to us? We are given temperature. Temperature is 22 degrees Celsius. You need to convert it to Kelvin. 22 plus 273 will give us, plus 273 will give us 295 Kelvin. Is there any other thing given to us? Yes, we are given volume. Volume to be equals to 46.2 centimeter cube. That is the volume. All right. Now we are looking for the weight. We are looking for weight. Weight is what? Is mass. We are looking for weight. Weight is mass. Now, permit me to continue. Remember, from ideal gas law, PV is equals to nRT. Okay? Number of moles is mass over molar mass. That means that what? That PV is equals to mass over molar mass. Then multiply by RT. What are we looking for? The mass. That is weight. Make mass the subject here. That will imply that the mass will become PV multiplied by M over, okay, RT over RT. So that is the equation we are going to use. That means pressure multiplied by volume multiplied by molar mass, then divided by RT. What do we do now? Let's clean this part so that we're able to see the board where we can solve further. Remember, M must be equals to PVM, okay, over RT. And remember I told you, anytime you are solving an equation with what? With the molar gas constant. Remember the molar gas constant is 0.0821 atm dm cube per mole, okay, per Kelvin. What it simply means is that anytime you are solving an equation with R using this word constant, your pressure must be in atm and your volume must be in what? Dm cube. If you look at our pressure here, it is in millimeter of mercury. So we must convert it to what? To atm. How do we convert? We divide by 760. Then we'll convert this what? Volume in centimeter cube to dm cube. How do we convert from centimeter cube to dm cube? We divide by 1000. So if we are to put, that means that our mass will become pressure, which is 732 over what? Over 760. Okay, that is to convert. Multiply by volume. Volume is 46.2 in centimeter cube. So divide it by 1000 so that it can be converted to dm cube. Then multiply by the molar mass. What is the molar mass? Remember the gas we are treating is oxygen gas. And the molar mass of oxygen is what? 32 gram per mole. 32 gram per mole. Then we divide by what? By the molar gas constant, which is 0.0821, multiplied by the temperature, which is 295 Kelvin. So when we multiply out, our mass will become 0.05, okay, 89 gram. Please use your calculator to ensure that I did not make mistake when I'm punching. So that is it. The mass of a gas is the same thing as the weight of the gas. From ideal gas equation is pressure multiplied by volume multiplied by molar mass over molar gas constant, then multiplied by temperature. If you put the values you have with their converting factors, we'll get our answer for mass to be this. So that is question number 3. Can we go on? Yes. Let us take number 4th question. Number 4th question. Okay? All right. The fourth question says the general gas equation can be obtained. The general gas equation can be obtained from the combination of option A. We have Avogadro's law and Boyle's law. Option B, Boyle's law and Charles' law. Then option C, we have Graham's law. Graham's law is Graham's law of diffusion. Graham's law and Avogadro's law. Then number D, you have Newton's law. And Charles' law. So which of these two equations, or which of the two equations can we combine in order to get the general gas equation? Now, general gas equation, if you must know, general gas equation is P1 V1 over T1 is equals to P2 V2 over T2. This is what? General gas equation. So if this is general gas equation, okay, that means I believe that it should be gotten from what? From Boyle's law and Charles' law. Why? For Boyle's law, V is inversely proportional to what? Pressure at constant what? Temperature and mass. This is what? Boyle's. Then Charles' law, V is directly proportional to what? Temperature at a constant mass and pressure. That is what? Charles. Okay? Then if we combine these two equations, let us know whether it will give us P1 V1 over T1 equals to P2 V2 over T2. Let us combine. Now, using variation in mathematics, we have the same volume here, so V become proportional. The other part will multiply it. 1 over P multiplied by V. Okay, I'm combining these two equations. V is 1 over T. V is proportional to T. So V will be proportional to 1 over P times T. That means that V become proportional to V over P. Okay? Okay? Oh, sorry. This is times T. Remember, 1 over P. Then times what? Times T. So here is actually 1 times T, which is T over P. Now, if we introduce a constant to remove what? The proportion, my V will become equals to KT over P. So what happens? We make the constant the subject of the formula so that the constant become PV over T. That is proportional, please. Proportional. Well, okay, from here is constant because, equal sign. Because I've introduced a constant is now equal sign. So K will become equals to this. Now, if K is equals to PV over T, under different conditions of pressure, volume, and temperature, we can now see that what? Our P1 V1 over T1 will be exactly equals to P2 V2 over T2. So this is exactly what? The general gas equation. So it is obtained by combining Boyle's law and Charles' law. Let's go to question 5. Let's take more questions. Can take question 5. All right. So question 5 says, question 5 says 4 grams of an organic 4 grams of an organic compound, 4 grams of an organic compound was vaporized at 250 degrees Celsius in a container of volume 0.25 dm cube. Okay, they said if the pressure of the gas, if the pressure of the vapor is 0.4 atm, what is the molar mass of the gas? What is the molar mass of the gas? So we are looking for molar mass here. Okay, all right, we are looking for molar mass. Remember, as a solution here, looking for molar mass, remember from the ideal gas equation that PV is equals to nRT. Number of mole is mass over molar mass. So PV will become mass over molar mass, okay, multiplied by RT. From this place, we can make mass the subject of the formula. So if we make, molar mass, we can make molar mass the subject of the formula. From here, can make it direct, molar mass the subject. That means that molar mass will become equals to mass RT divided by what? Divided by PV. So that will be this. And then we want to get the molar mass of the gas. It becomes the mass given to us. The mass given to us is 4 grams. So it's 4 multiplied by molar gas constant is 0.0821 multiplied by the temperature given to us is 250 degrees Celsius. We convert to Kelvin. So by adding 253, if we add 273, sorry, if we add 273 to 250 degrees Celsius, it will give us 523. 523. That will be the temperature. Then divided by the pressure. The pressure given to us is in dm cube. The dm cube is volume. Is pressure given? Yes, pressure is given to be what? 0.4 atm. So 0.4 atm. That is the right unit to use. Then multiply by what? The volume. Volume must be in dm cube. So that is the right unit, 0.25. So when we multiply out, we will get the what? The molar mass of the gas to be 1717.53 gram per mole. I hope it is very huge, but that is the answer. So we have gotten the answer of the molar mass of the gas. Now we take one more question, okay? One more question. This one, let us take a question that might be, okay? Let's take one more question. All right. The question says the valve between a 6-liter tank, valve between a 6-liter tank in which the gas pressure is 12 atm and 18-liter tank containing gas at 6 atm is opened, full stop. After the pressure equilibration, at constant temperature, what is the final pressure in the two tank? What is the final pressure in the two tanks? Look at this question very well. I think it is a technical because we have what? A tank and another tank, okay, connected. Their gas is here, gas A, gas is here, and their gas is here. The tap is opened up for two of them to mix and equilibrate. Remember, the gas here have its own pressure and its own volume. This one have its own pressure and its own volume. But when the tap was open, the two will mix and equilibrate and become at a constant pressure. We are being asked to find that pressure after equilibration. Now, what is the pressure of this gas and the volume? That is P1, V1, okay? Now, what we'll do is this. Let us get the number of moles of gas that is here and also get the number of moles of gas that is here. Remember, number of moles or from PV is equals to nRT. You agree with me that the number of moles is equals to, okay, PV over RT. That is the number of moles. That is the number of moles. I hope you can see. That is the number of moles. Okay? Now, let me get the number of moles of the first gas. The number of moles of the first gas, N1, will become equals to P1 V1 over RT. Yes. Remember, this was done under constant what? Temperature. Because we have constant temperature, okay? We are not going to take what? T1. Because the temperature is constant all through the experiment, as we were told. Now, the number of mole of the first gas, N1, will become, what is P1? Our P1 is 12 atm. So that is 12 multiplied by V1. Our V1 is 6 liters, 6. Then divided by RT. That will give us 12 times 6. 12 times 6 will give me 72. Yes, 72 over RT. That will be my N1. What is my N2? N2 will be equals to P2 V2 over RT. Yes, from this P2 N2 we go with P2 V2. Now, what is my P2? My P2 pressure 2 is given to me as, okay, 6 atm. So I have 6 multiplied by the V2. V2 is what? 18. So I have 18 over RT. So if we multiply 6 by 18, I have N2 to become 108 over RT. So I have gotten my N2. Okay. Now, having obtained my N2, then after equilibration, what happens? When two of them are being equilibrated, of course, you know that the volume will be different, while the pressure will be different. After equilibration, we are looking for pressure P after equilibration. Okay? What is the number of moles after equilibration? After equilibration, the number of mole N will become N1 plus what? N2. Because you have equilibrated two gases. Those two gases, one have its own number of mole, while the other one have its own number of mole. So when they are mixed together after equilibration, the total number of mole there now will become N1 plus N2. That will give us our N1 is 72 over RT plus our N2, which is what? 108 over RT. Okay, that will give us 180 over RT. If we sum them up, it will give us 180 over RT. Then, when two gases mix together or equilibrate, you should also expect that their volume will be different. So the volume of gas A and volume of gas B, when they come together, there will be an increase in volume. That means the total volume after equilibration also will become V1 plus V2. So what is my V1? 6 liters plus 18 liters, which is V2. Total of what? 24 liters. Okay? Now, I brought out my final parameters after equilibration. Then how do I now get what? My pressure after equilibration. Use PV is equals to nRT. Then your pressure becomes nRT over V. So the pressure of equilibration P will become the number of mole of equilibration, which is what? 180 over RT. Okay? Then multiply by the molar gas constant, multiply by temperature, that is RT. Everything divided by the volume of equilibration, which is what? 24. Expect that what? That RT will cancel what? RT. So P will become exactly equals to 180 degrees. 180 divided by 24. 180 divided by 24 is about 7.5 ATM. Okay? So that is the question and the answer. I would have liked to or love to take another question. I would have loved to take another question so that we'll have more and more questions to solve. Okay, let me take one more question. I'll take one more question. The question says, at standard temperature and pressure, standard temperature and pressure, okay, nitrogen, standard temperature and pressure, nitrogen weighs 1.25 gram per liter. What is the weight? What is the weight of 700 centimeter cube of nitrogen? Okay, at 800 millimeter mercury and 27 degree Celsius. So let us take a solution. Okay, now at standard temperature and pressure, what is standard temperature and what is standard pressure? Now standard temperature T is 273 Kelvin and standard pressure P is 1 atm. At this standard condition, we are told that nitrogen weighs this. So the weight W is equals to 1.25 gram per liter. Okay? All right. Then I say, what is the weight of 700? That means at a what? Volume. We are giving volume. Okay, what is the weight? Okay. of 700. Am I sure of the equation? Okay, let me go back to the question. Okay, yes, I'm sure that is it. What is the volume of what? 700. 700. So we are looking for, remember, at standard temperature and pressure, a gas at standard volume will be 22.4 dm cube. Before I forget, yes. Standard temperature is 273. Standard pressure is 1 atm. The weight given is what? 125. Remember, standard volume, that is what I was looking for, is 22.4 dm cube. Now they are now saying at a volume V2 of what? 700 centimeter cube. And the pressure P at 800 millimeter mercury. Okay? And temperature T of 27 degrees Celsius, which is 300 Kelvin. We should find the weight W2. Should find the weight W2. Okay. At a standard temperature and pressure, which is a standard temperature, standard pressure, standard volume, that this nitrogen weigh this. Then under 700 centimeter cube, 800 mmHg, and 300 Kelvin, what will be the weight? Now I told you, weight in chemistry is mass. So they are asking us to find the mass of the gas. How do we get the mass of the gas? We can get the mass of the gas from ideal gas equation. Now, let's say PV is equals to nRT. So PV will be equals to number of mole is mass over molar mass. Okay? Multiplied by RT. What we are looking for is what? Is the weight, which is mass. Now, if we cross multiply, we will have a PVM is equals to MRT. Okay? Now, if we divide by R, let us divide both sides by R. We'll have PVM over R is equals to, okay, MT. Good. MT. Then that means that M over R is equals to MT over what? Over PV. Yes. Now, if you look at this, you find out that the gas that was used in the experiment is nitrogen all through. That means molar mass is constant. Now, constant molar mass and constant what? R, which is a molar gas constant, means that M over R are all constant. So we take it to be K. K becomes equals to MT over PV. If this is constant, what happens under what? Standard temperature and pressure. What will happen? At different conditions. If K is equals to this, that means at different conditions, M1 T1 over P1 V1 will be equals to M2 over M2 T2 over P2 V1 under different what? Conditions. Now, what we are looking for is the second mass, which is weight. Okay? If you permit me, I can, instead of W, I can use M. Instead, that is M1. Instead of W2, I can use what? M2. Because weight is mass. Okay, let us put the parameters we have got, all of them, into the equation. So, my weight 1 is 1.25 multiplied by temperature 1, which is 273 Kelvin, divided by pressure 1 is given by 1 atm, that is 1. Then multiply by volume 1. The volume 1 is 22.4, okay, in dm cube. That will be equals to weight 2 I'm looking for, multiplied by temperature 2. temperature 2 is 300 Kelvin. Then divided by volume 2, that is P2V2. What is volume 2? Volume 2 is given to us to be 700 centimeter cube, but it need to be in dm cube. So it will be pressure 2 first, which is 800 mmHg. It need to be in ATM. So it have to be 800 over 760. Somebody might ask, why am I dividing by 760? To convert it to ATM. Then multiply by the volume, which is 700. Remember, the 700 is in centimeter cube. So you need to convert it to dm cube by dividing by 1000. Okay? So having taken this, we can make the mass the subject of formula. So the mass now becomes equals to 1.25 times 273 multiplied by 800 over 760 multiplied by 700 over 1000, everything divided by 1 times 22.4 multiplied by 300. So when you use your calculator, okay, you will get that the mass is 0.84 gram. 0.84 gram. 0.84 gram per what? Per liter. So I think I've not made any mistake while solving. Okay, so cross-check what I gave by punching your own calculator. Okay, but I've given you the processes from where you can get the mass. Thank you very much. I hope you enjoy this class. Okay, please subscribe, okay, share and like the video. It will help A-level students. It will help those preparing for WAEC, JAMB, okay, NECO, NAPTEP, and so many of them. Thank you very much. Okay, all right.